recording. There we go. Okay, let's go ahead and put down, this is for level 1. There was a lot of information, a lot of game rules that we want to establish first here before we get started. What was the very first one before you even started playing the game? It was that intro slide. What are we supposed to...
Leave the box alone
so it can grow. But the very first screen, get the Dragonbox alone. Is that like the rule that you have applied on every single frame that you've been trying to get through? Do you try to get the Dragonbox alone?
Yeah.
Yes, from this point forward. That's why they said it in that very first introductory slide. Your entire goal is to get the Dragonbox alone. You do whatever you have to do with the powers that are given to you to get the Dragonbox alone. Now, in algebra, what that means is we are solving for x. We're trying to get x, or the variable, or whatever it is. If it's an a, or a b, or a y, we're trying to get that by itself. Let's go ahead and just write that down as well. Get the variable by itself. A lot of times it'll be x, a lot of times it'll be n, but it could be a variety of variables. So just kind of get that into your head. That's my goal. Just like the Dragonbox, I got to get the variable by itself. Hey, did the Dragonbox change as you went through the game?
Yeah.
Did he become a variable?
Yeah.
Like an x or something? How did you know that was still the Dragonbox? Oh, the little stars that were kind of swirling above it. It was that special Dragonbox X that we had to get by itself. Okay. What happens when we're solving equations? We end up with things like this. We get the variable by itself, and it equals something like a equals 3 or x equals -7. That's our goal. We want the variable by itself. We can think, okay, the Dragonbox is by itself, and now we know what he's going to eat. We know what he equals at this point. The algebraic rule that you will probably hear is they will say isolate the variable. What does the word isolate mean? To put by itself. Okay? Sometimes we have to isolate things. We got to put them by themselves. That's exactly what we're doing in algebra all the time. We want to put that variable by itself so we know what it equals. Number 1 rule. Okay, now the next thing that you learned was this. You probably have this on your paper. What is the rule that we have to do here? We have to do what?
Get rid of the 2 green things.
Okay, we have to tap the green swirling vortexes, and what happened when we tapped them?
They go away.
They went away! Okay, I got a tough question for you. Don't yell it out loud. Think it in your head. In math, what number are the green swirling vortexes?
0.
Shh.
Oh.
It just bubbled out of him. He couldn't contain it. What number are the green swirling vortexes representing?
0.
0. Do we need 0 in equations? No. Do zeros change anything? No. No. You can add 0 to anything and it won't change. Could I add like 100 zeros to something? Will it change it? No. I could have 100 swirling green vortexes and I would have to tap them all and it wouldn't change anything. They just disappear. Okay. Well, that is a algebra rule. So in the game Dragonbox, we have to tap the green vortex. Now, if your parents go through and look at your notes, the game rules are not going to make any sense to them at all. For you, hang on just a minute. Yes? Yes, I can. For you, the game rules are going to be what you actually picture. And by the way, I did email all of your parents to tell them that we finished with transformations, we're moving into algebra, that you will have assignments most every day. Speaking of, before you leave, here's yours. You will have assignments most every day. If you get it done in school, great. If not, it becomes homework. And I told him, if you struggle, you should be able to consult your notes because we always go over an example in the notes first so that you can do what it is to practice, okay? I also gave them a link to the live binder. So that way they can have that, and there's lots of helpful websites on there as well, okay? So just an FYI, we probably will have assignments most every day. Okay, going back to this. If we tap the green vortex, we do this to make it go away. And I'm going to add to this what it's actually representing. The green vortex is actually a fancy zero.
Yeah, I thought it looked like a zero.
It kind of looks like a zero. It's just swirling green, but it kind of looks like a zero. It doesn't affect anything, but it's nice to get rid of them. It was that first easy rule. Okay, mathematically, what would this look like? When we're solving equations, you might get something like this. And pretty soon you won't get this anymore because you know to get rid of it. Do we need that x plus 0?
No.
No, the plus 0 we can tap. Poof, it goes away. So really, what do we have left?
4.
We have the x, which is the Dragonbox, and x equals 4. We don't need to have the plus 0 there because x is still x, even if I add 0 to it. If I added 0 to Trinity, she would still be Trinity. Okay? I could add 3 zeros to Jasmine, and she's still Jasmine. Now, the algebraic rule is, it is the additive. What is the word for additive? What's going on there? Additive means we are adding. So I was adding zeros to Jasmine. Jasmine stayed Jasmine, even though I added 3 zeros to her. So it's the additive identity. No matter what I add a 0 to, it will keep its own identity. So the additive identity property. Wow. The game was showing us one of the properties that we need to know about. You'll see this come up a little bit later. Okay, then you got another power. Now, you still have to get the Dragonbox alone. That first rule, that first power, that first thing, your goal is always there. What was the power you learned on this one?
But if they're the opposite, they can cancel each other out.
Match.
The opposites match. So you're looking at this firefly guy, and we've got a red and orange firefly, and you say I can put it with the the purple and black firefly. What happens when I put them together?
They cancel the green vortex.
Oh, they cancel out. They turn into a swirling green vortex that I can tap, and it goes away. Mathematically, what is that showing us?
It could be a negative.
Which one do you think is the negative?
The black.
The black and purple. Which one is the positive? The red and orange. Just, you know why? Okay, I don't know why that's the negative. I'll tell you why my brain said that, though. How many of you have been in photography and you work with negatives and to create your pictures? For those of you that have been in there, help me out here. On the negative film, before you create the picture, if it is a white object, what color is it on the negative?
Black.
It is black. And then when I print the picture, it is white. So if I were to take a picture of Tyler in his white hoodie, the negative, it would look like he was wearing a black hoodie. We'd print the picture and it would be white. So I think that's probably why I put the purple and black icon as the negative, just based on the whole photography thing. Okay? So you're right. Positive and negative numbers. If they're the same, these are both the same fireflies, and I put them together, what happens?
Then
Then they go away. They cancel. Let's look at an actual problem here. Oh, we got to get our game rule down. We talked about it. Okay, we can match opposite colors. And we match them to do what? Why are we matching them? To make them disappear. And actually, do they really disappear? They actually create what? They create the green vortex, which now in our brain, we see green vortex and we think 0. But that's a huge power that we learned. And then, did you guys get to the point where those icons are at the bottom of the screen, and if you tap them, they will change to the opposite? Yes. So like if you needed a positive one, like the light colored one, or you needed the purple black one, you could tap it and get whichever one you needed to be able to cancel out. Yeah. Now, mathematically, what does this look like? Okay, if I took away the puffer fishes and the turnip heads and the dragons, what does this look like with numbers? It would look like this. Negative 23 plus x, which is my Dragonbox, plus 23 equals 14. Yeah, which ones are you going to cancel out? The negative 23, you're going to match up with the positive 23. Poof, we get the swirling green vortex. Tap it, it's gone. Now, I could have said x plus the swirling green vortex equals 14. Because technically, isn't that what's going to happen? Yeah. But do I really need to do that?
No, you can just x equals 13.
Right, because the additive identity property says tap that swirling green vortex, get rid of it. You don't need it. X really just equals 14. Notice how simple that is. Look at how confusing we started. We had a lot of stuff going on, just like your boards do on the game. Then we simplified it. It got shorter, and then we tapped that swirling green vortex, and now we just have what we needed. That is what algebra is all about. This matching the opposites does have a property name. It is an additive because we are still adding. We're putting together those opposite colors, but it's called the inverse. Inverse is kind of the same as opposite. So we're putting together the opposite things, and that's the property that this was showing. Pretty cool. That was a pretty good power that we had, is being able to match up the same thing, but one's a positive and one's a negative. Okay? Okay. Now, I noticed this yesterday. There were times when we had a yum, and then there were times when I walked around and you got a yuck.
It was because the yum, if you got a yuck, it was because there was a match in the other box.
Okay, I printed off some yucks that I saw. Okay, this is an example of you solved it, but it was still yucky. Why is it yucky? Why? What happened?
You didn't tap it.
I didn't tap it. I didn't either have the time or I forgot to tap it. It still solved it. It was good. You got to move on. But they're saying, do you really need that 0 over there? No. No. That's exactly like this one here. This one probably would have been solved, but you would have got a yuck because you didn't simplify it all the way. This here is also a yuck. It's solved, but what happened? I could have matched these two up because one's a positive and one's a negative. Notice that we, instead of puffer fishes, we now have like numbers. And we can match those up because they both represent 5 and negative 5, put them together, and boom, we get 0, the swirling green vortex, which we better tap. Okay, a yum in algebra means you have simplified it all the way down. You have found everything that you need to match up, that you can tap. You're good to go. That is one of the big things in algebra, is to always, always simplify. Make your life easier by making the problem easier. Okay? Sometimes you're going to be solving things and someone's going to be solving an equation this big. And you're going to be solving an equation this big. And they're going to look at you going, what? That's really easy. That's because they added too many things. Did any of you add too many things to your Dragonbox? And you're like, I've got a problem going on here. I got a lot of stuff to get rid of.
Once.
Yeah. Luckily in Dragonbox, you could click replay and try to figure out how can I do this easier. That's what the yum is all about. Get things simplified. Like this, x equals 17. That's as simple as you can get it. Now, a yuck is basically not simplified. You probably forgot to do something. It's probably looking a little bit more confusing than your neighbor's. And you're probably going, wait a minute, theirs looks nicer, mine looks kind of messy. You just didn't simplify everything. It would be like this. X plus 17 plus a negative 17 equals 3. Yours is still looking pretty long, isn't it? What do you think your neighbor did? They matched those up and they said, you know what? The additive inverse property says, get rid of those. They're going to be 0. The additive identity property says, get rid of the 0. We basically have x equals 3. Okay, there's really not a property. It's more of a way of thinking for the algebraic rule. It's simplify before solving. It'll make your life a whole lot easier. Okay? If you don't always remind yourself to simplify, you're going to be working with really, really long equations, and your neighbor's going to be working with these really short, easy ones. And you'll be like, I want to get there. Always simplify. Now, I have one more rule. What is my time? Oh, good. We still have time. And I ran out of room on my front page, so I'm going to have to flip. If you still have room, I would probably say like about this much space. Okay. Yeah, you should be good. I do have several examples. You may just have to write a little smaller. And know that you can always flip over if you end up.
Second.
Yeah, you'll be good. Okay. The last thing in level 1 was this cracking screen.
If you don't put it on the other side, you'll die.
Now, this is what I noticed. Okay, I got to look at this. Okay, I bet I had to add the pink firefly to this side. Why did I add the pink firefly to this side?
Because you need to match that and leave the Dragonbox.
I needed to match it, and if this was negative, I needed a positive. Okay, so I needed to match it with its opposite. Since I put that one on this side, the cracking screen was saying, hey, don't forget, you gotta put one on this side. What I do to one side, I gotta do to the other side. There you go. Okay, let me flip. We're still in level 1 notes. So in the game, the rule was the cracking screen. And I don't think they ever told you anything about this. I think you figured this out on your own. That the equation is not balanced. That's why it's cracking. You added something to one side, and now it's starting to crack because it's not balanced. Does this remind you of anything that you've done in elementary school?
Yes, with the little scale thing.
Ah, the little scale, the hands-on equations. So you did hands-on equations with little pawns that you could pick up and all of that. Now you're doing Dragonbox. Same thing. It's just now you're working with puffer fishes and turnip heads.
I dislike
Okay?
that so much.
I know, but it set the scene so well. Okay, I'm going to put down what you guys just said. What I do to one side, I have to do to the other. You will never ever go wrong if you constantly keep this in your head when solving algebra equations. Oh, with my writing, I've been writing in front of, for a long time. When you take that college course of how to write in front of students, you do a lot of practice. It takes a whole semester of just writing. No, I'm joking. You just get better at it. There is a property name for this, and it actually makes sense. It is the property of equality. Why do you think they chose the word equality?
Because it's
It's equal. You are treating each side of the equation or each side of your Dragonbox game board equally. Let's look at a problem with numbers instead of pufferfishes. 23 equals x minus 7. Now, if you like to imagine, the little turnip heads and the pufferfishes and all of that, we can imagine that this x is my Dragonbox. It has the little stars around it. I have a negative 7, so I would probably be imagining it as that purple-black firefly, okay? And then I have 23 over here. He's positive, so he's probably like a golden green pufferfish, okay? What am I going to do to get rid of that negative 7? I'm going to add 7 to it. I'm going to bring up a positive 7, and I'm going to put it right underneath there. Now, I'm going to say, even when we're solving these really easy equations, I want you to show every step of the work that you are doing. I know you're going to say, but I can do it in my head. Don't worry, I've heard it for 20 years. I know you can do this in your head. I know I can do this in my head. But I also know where we're headed, and we're going to get to really, really long equations, multi-step equations. You want this process to go so smoothly you don't even have to think about it. Okay? So I added 7 over here. Am I done? No. What do I have to do?
Cancel them out.
No.
And add it to the other side.
Ah! The screen is cracking. I have to add it to the other side. What I do to one side, I have to do to the other side. Now, I'm going to put a big line underneath there because in the game, it just changes for us. Okay? On paper, we need to say, okay, the equation is going to take on a different look now. What's going to happen with this negative 7 and positive 7? It's going to turn into a 0. I can cross it out. Poof! Swirling green vortex. Do I need to put plus 0 down here?
No.
No, I'm going to tap it out anyway. So I might as well just skip that step.
30.
I still have x over here. Now what do I have on the other side?
30.
30.
30, 30.
Now here's the greatest thing about algebra. I can go through and I can now take this 30, which is x, plug it back in for x. 30 minus 7 is 23. It checks out. I know before I hand in this homework, I got it right. Let's do one more real quick. 14 plus x equals 9. I've got a positive 14 over here, so what am I going to drag up there? I'm going to put a negative 14. And if I put a negative 14 on this side, I'm going to have to put a negative 14 on this side. What I do to one, I have to do to the other. I know things are going to change, so I'm going to draw my line. Poof. He's gone, tapped out. We don't need to worry about that swirling green vortex. I have my Dragonbox alone, and my Dragonbox equals negative 5. I can plug it back in. 14 plus a negative 5. Does that equal 9?
Yes.
Check, I got it. Okay? Okay. I knew this was going to take most of the time. You do have an assignment today. I will post these notes on the live binder if you want to go back over them tonight. Your assignment matches all the rules that we just went through in Dragonbox. I just put numbers to it. In fact, I used some of the exact same screens, but I just put numbers to the question.
Oh, you
had extras? Okay, real quick. Some people are looking at this and they're like, what do we really do with this? If you look at the tap the green vortex, what do we do with the green vortexes? We tap them and where did they go?
Disappear.
They disappeared. So my plus 0, I really don't need them there. So what is 1.5 plus 0? 1.5. Okay? Let's look at rule 3 down here. Match the opposite colors. What's going to happen when I take the 15 and I match it to the negative 15? It's going to cancel out. So what do I really have? X is going to equal, actually it's just x plus this actually equals just x. That's all I got. Okay, so when you have things as you work through that you can cancel out, just literally cross them out and be like, okay, I would tap this out. It would end up being a green vortex. By the time you get to Rule 5, this is where we have all of the examples with numbers. Show your work every step of the way. I doubt this takes you more than 10 minutes. The top 3 parts will take you seconds. Rule 5, you may want to put a little bit extra time. Okay.